Good morning, everybody. Today we'll be, for Chicago Water Week, we'll be learning about the carbon neutral wastewater treatment experiences out of Denmark. We have a fantastic panel. My name is Graham Miller. I'm a senior researcher at the Energy Resources Center at University of Illinois, Chicago, where I am the assistant director of the Department of Energy's Combined Heat and Power Technical Assistance Partnership. I'll be moderating this panel. We have four excellent panelists that will be discussing Denmark's experience in the wastewater sector and how these experiences may translate to Chicago, the Midwest, and the United States as a whole. So I'd like to introduce our panel. We have a brief presentation after that, and then we'll get into a discussion on Denmark's experiences. So please feel free to leave a question in the Q&A box. We'll be getting to those towards the end after the presentation, but we really want to encourage all of the participants, all of the attendees to ask questions to make this a more of a discussion. So let me introduce our panel. Today we're joined by Mads Warming. Mads is the global head of water and wastewater at Danfoss Drives and vice chairman of the board for the Danish Water Technology Association. He has more than 25 years of experience with process optimization and online control of water supply facilities, water distribution, irrigation, wastewater canalization systems, and wastewater treatment facilities. Previously, Mr. Warming has been the CEO for Danfoss Analytical, where he helped develop a new groundbreaking analytical sensor for the global water and wastewater industry. He has been involved in EU's Symbiose project, aiming to develop new innovative control strategies for wastewater treatment plants, as well as the needed online sensors to control those facilities. For these developments, Mr. Warming received an Innovation Award from WEFTEC. Additionally, we're joined by Torvald Peterson. Torvald Peterson is the CEO of Nissen Energy. Mr. Peterson has worked with the decentralized energy sector since 1992 and has held the position of CEO of Nissen since 2005. He has transferred the company from a service provider to a solutions provider for decentralized energy systems. Today, Nissen Energy is a leading company for decentralized energy systems in the wastewater sector in Denmark and is increasing exports to Scandinavia, the greater EU, USA, and other countries. Before entering the energy business, Mr. Peterson served as a naval officer in the Royal Danish Navy, leaving with the rank of lieutenant commander. Mr. Peterson is educated as a marine engineer and holds an MBA in change management from the University of Aarhus in Denmark. Today we're also joined by Nick Moninga. Nick Moninga is retired from his role as a general manager of the Downers Grove Sanitary District, where he oversaw the planning, design, construction, and operation and maintenance of facilities to co-digest fats, oils, and greases and produce energy in a CHP system to create a net energy-producing wastewater treatment plant. He is currently helping the Energy Resource Center at the University of Chicago with its Teach AD assistance program using U.S. EPA evaluation tools to promote co-digestion of food waste and energy recovery at wastewater treatment facilities in the Midwest. And lastly, presenting today, we have Klaus Homan. Klaus Homan is the Chief Operating Officer and Chief of Strategic Development for Aarhus Water Limited in Aarhus, Denmark. The focus of his work is development of production capacity and process optimization in water, wastewater, and resource recovery systems. He is also responsible for the implementation of international strategy, including development of the Water Technology Alliance. Mr. Homan is also chairman of the board, chairman and board member at the newly established Danish Water Cluster and Danish Industry Water, where key players in the water industry sector co-create the future related to water, digitization, and UN development goals. He also serves as co-op member at the Stockholm Water Foundation and Stockholm International Water Institute since 2020. So thank you. I'd like you all to welcome our speakers, and now we have a brief presentation from Klaus Homan. Klaus?
Thank you very much. I believe you can hear me very well. So could I please have my first slide? Next one, please. And next. Next. Yes. Thank you very much. I have a lot on my mind, and I have some minutes to give an introduction before you'll have time to ask questions and also have a debate. And first of all, I'll mainly speak about carbon neutrality, energy, and how that has taken us to where we are. If we take the next slide, then Aarhus Vand was established in 2010 as a limited company. We are 100% owned by the municipality of Aarhus, which is the second largest city in Denmark. And we serve the whole water circle, both drinking water, wastewater, and stormwater. And when we were established in 2010, that was because the regulators decided that we should improve our production by 2% every year, meaning that we should cut up 2 to 5% from our operational and maintenance costs, which was a hard one. On the other hand, that's what we have been doing for so many years. And we have also achieved over the last 10 years to cut 20%. We were very concerned about it when it started, but it seems to be a very positive driver for our development. If we take next slide, then it shows the 2025 strategy for Aarhus Vand. That means the purpose of Aarhus Vand is actually to create health with clean water for people and planet. Sometimes we as utility people forget that we are into health business. Some of us might think we are into mechanical, electrical, or automation, or any kind of other business. But the purpose why we are here and why we serve our customer is mainly related to health. And I think we especially know that during the COVID-19 crisis that we're still having, but also see how we can contribute to investigation in sewer system to clarify further development. The basic for our services, we call that excellent basic services. That is supplying human with clean water and purified wastewater, resource efficient and climate adapting. It's a big challenge, but of course the strategy should also drive challenges for us. And for that, we need innovation, which is the key for future development, for our own purpose, but also commercialization, because it shows that we can do it in an efficient way, so to speak. And globalization is, like the session today, very important for sharing knowledge and learn from each other in order for us in the world to meet the climate goal. Some might say the sustainable development goals, or even bring good services to the customer worldwide by sharing different opportunities. Please, next. What is clean water is just a byproduct. That's a speak that I've done through WEFTEC at a certain time, trying to speak about resource recovery. But it's not a joke. We take clean water in Denmark for granted, and we are lucky to be able to do that. I think in the world, about 80% of wastewater is only being treated. And that means that we have a huge impact on the climate effect by non-treated wastewater. So taking water for granted, we sometimes also forget that it's the most important things for life. But let's see, if water is the byproduct, what is the actual product and the focus we should take? Look at the next slide, for example. Like we as individuals needs to have the basic in place, which is normally food for us to survive. And then we can establish a higher level of value also for human beings. If we talk about wastewater, then clean water, maybe below this triangle here, is the most important things. But you see, we produce a lot of different stuff: energy, water, materials, chemicals, health and lifestyle products. Some of them are produced today, others are actually coming up and is available in lab services. So it is quite interesting to follow that track and maybe not only focusing on clean water, energy production, but also different high value product like Struvite, for example, which is also part of our product portfolio. Please, next. Marselisborg, wastewater treatment plant or resource recovery, that can be questioned, is probably one of the most well-known plants in Denmark and even worldwide. It is an energy producer, which is different from just producing clean water. So when we looked back at what we have been doing, we also find it might be one of the most sustainable plants. Look at the next one. This is just like showing an old car, so to speak, because you can see the plant is 220,000 PE, and it's been built from back in the 60s and up till now, and mainly adding new technologies and so on to the old existing concrete tanks. So nothing new and fancy as such, but I'll come a bit into that. It's just another plant like many others, maybe small, medium-sized plant. Next one, please. What is the core of that plant, the energy production? That is actually biogas production. Biogas being burned in combined heat and power system. This one delivered by Nissen Energy. Remember the red color, Torvald. And then, of course, electricity produced for the grid and sold to the grid, and also heat being sold to a district heating system, and also heat being taken back to the digester. And then the final slot being taken to agriculture, farmland. And this is an area that we don't like at all. We want to cut out that number 5, because we don't believe it's good to take biosolids on farmland, because in Denmark, we rely only on groundwater for drinking purpose. And we are a small country, and having biosolids just on top of our groundwater reservoir is not a good solution. At least our customer don't like it. So we work hard to get new resources and biochar as an options, and maybe even more different options. Looking at how it has developed over time, please, next one. You can see how consumption and production of energy at the Marselisborg facility is taken out. In 2011, you see a big change. The green curve, actually, the production increases and the consumption decline, which is very important if you want to be energy positive. And this energy strategy has been going on since 2005, 2006. So we're really working hard to get there where we are today. And where are we actually? Looking at the next one, please. This is a graph showing that in 2016, we produced the blue column 50% more electricity than we used at the plant. And heat and power combined, we had 168%. This is the maximum production we had on electricity. And you know, 1 year is different from another. Maybe the amount of water from rainwater, because we have combined sewer system, comes in and make it difficult. And even introducing a new struvite plant at Marselisborg took some of the energy and also efforts from our energy production. So it's a trade-off, so to speak. But on average, you can see to the right, 128 on energy, on electricity, and 148 on energy total. It's not so bad. So I congratulate my people on doing what they have been doing and still doing. Next one, please. What is the main activities that make these changes? From an energy consumer to energy producer. If you look at the yellow one, actually maybe 70% is caused by automation and SCADA system and sensors that allows us to run 24/7, 365 days a year, at best production capacity. And that is highest quality online, with the best knowledge from our operators put into a computer system, because we only have people at the plant 6, 7, 8 hours a day and no one during the weekend. So it's a full automation plan. And then you can see different techniques on the blue one that play an important role. I would say when it comes to technique, this is the reason, but there should be another one showing people on the white part, which is the most important because they actually drive the change and the motivation to implement technology and difficulties in getting the sensors to work right and showing the right result always, so to speak. Please, next. Here you can see activities as a summary of what leads us to the energy producing plant. And to the right, you can see the return on investment is less than 5 years, which is fantastic. And of course, it's taken out from a Danish environment where we pay fees for pollution in many ways, and also get a good price for our electricity in order to produce green electricity, and also allowing us to sell heat throughout the year, which is a big benefit. But our customer wants to buy our stuff in order to save energy for the society as such. You can see at the bottom the total increase in production is 4.4 million kilowatt hours a year, which is a lot, and the reduction in power is 1.1 million. The savings in money, when you talk about a reduction in operation and maintenance cost, that leads, this saving here is equivalent to 1 year's saving in the whole company, driven by the regulators' demand. So it's actually a lot just by focusing on energy. Next one, please. But energy self-sufficient and carbon footprint at the Marselisborg catchment area is another highlight that I would like to look into, because having energy and carbon footprint, that's actually a double challenge. It goes hand in hand, but it's not the same. Please look at the next one. Here at the left side at blue, you can see our service area in the municipality of Aarhus. The municipality is all shown in red here. If we take the center of Aarhus, town center, where it's most populated, we have 220,000 people in that area, in the Marselisborg catchment area. And if you show on the next slide, it gives us a result. If we take energy used for water and wastewater distribution, water taken up from 90 meters of well, distributed to the customer, wastewater pumped, in some cases back to the wastewater treatment plant, treated and discharged in the Bay of Aarhus. And all that added up and related to the energy that we produce in the same area at Marselisborg plant shows us that we are able to produce up to 99% of the energy needed for the whole water circuit. That is amazing. And this one just goes to 2018, and we are this year doing it even better, so we're getting closer to 100 again. This perspective has huge perspective on a global scale, so that's worthwhile trying to copy if possible. And you might think that even energy for water distribution isn't possible, but the figures you can see to the right is 0.5, 0.65, and so on. We actually below 0.50 this year on energy uses for drinking water distribution. So we can reduce our use of energy even on drinking water, though wastewater is the main energy producer. Next one, please. Over the last years, we have looked a lot into CO2 emission. And if we take the emission at the same area at Marselisborg plant, you can see the black column actually shows that our CO2 equivalent emission is quite high. And what is causing that? That is water production and distribution, of course, is high and blue. That's because we still have not fully green electricity to drive that delivery. Denmark is in a transformation for green electricity from wind farm and others. So over time, that electricity will be green, and now CO2 emission will be far less and even zero. But you see wastewater transport and greenhouse gases, and also our sludge disposal both have a positive impact on CO2, but the wild card or the showstopper is actually greenhouse gases. The more we measure these gases, we can see that the biological processes actually add to that. So that has to be a focus for us in the future when we talk about climate zero from wastewater treatment plant. And I think many are not even aware of the impact we have from these gases. So instead of focusing on energy only, the future focus will be climate and resources, and energy production is of course an important part of that, adding to less energy, less carbon impact. Next one, please. I'll bring a little bit from the Minister of Environment in Denmark about the regulation in Denmark, which is totally different from the US. And I don't want you to take that into your hand directly, but maybe to understand that in our situation, regulation and innovation can actually go hand in hand. And for me, innovation is about fulfilling ambition. So if a regulation is done in a smart way and not in an unproductive way, it is possible. Look at the next one, for example. You can see that from 2018, there's been environmental performing benchmarking. And I know WEF is doing something similar on resources and also energy production, etc. And it shows that the Danish water sector on average is actually 70% energy self-sufficient. And Marseillesborg plant is mentioned for one of the top in class on 150% on the electricity side only. If we take the next slide, then we can see that what's coming next in Denmark, based on our national climate law and action plan, will be that 70% reduction of Danish CO2 emission should be established by 2030. That's a national target. And for you to know that the latest Danish government was actually elected based on their climate strategy, which they are about to fulfill. Some of us think that they have not been there good enough yet, but it's coming. And this ambition also showed that number two says that threshold for nitrous oxide emission should be put in place for plants above 30,000 PE. So they know and we know that we had to look into that in order to look for a better climate. And then the Paris model for an energy and climate neutral sector means that we as utility had put in our own 2030 ambitions and added it up to see where we can be in 2030. And I will show you what the Danish utilities have set in as ambitions for the future. Look at the next one. And that means to be energy neutral before 2030 and climate neutral, energy neutral for wastewater sector before 2030 and total water sector climate neutral before 2030. And if we look at the next curve, you can see about the energy consumption. Here we have three. We have the drinking water, which is green and flat. The energy consumption for drinking water. For wastewater, we expect that curve to go down because of energy production. And that actually adds to the blue water for the wastewater total to be zero in 2030. If you look at the next one, which is carbon footprint, then you can see we will hit the same curve in 2030 for the water sector as a whole. And of course it's ambition and anyone can put in ambitions, but we are very much on that track already. So I'm sure we'll meet it. And that is not really a regulation. It's for the regulator on the Minister of Environment to put up a shared vision for Denmark to follow, and also for suppliers to add technology that allows us to go there. Next one, please. Aarhus is growing, and many cities around the world are growing even faster than Aarhus. And Marseillesborg's plant is getting too small. We're also centralizing from 4 plant to 2 plant. So in 28, we expect to have a new plant called Aarhus Rewater. And that plant will be the most ambitious resource recovery plant in the world. We put that out as a resource recovery plant, but we can see now, after a couple of years of ambition, that the climate neutrality is equally important. It's not only about resources. Clean water, first of all, climate neutrality, and then, of course, resources in a circular economy. And the interest about that plant is that we established not the work on that plant just to build a plant, but to define ambitions for innovation to deal with. And you can see in the circle a number of these, there were 15 totally, that Rewater should be placed in an area where it contributes to local environment. You have a new performance. It should be a learning plant. We should be able to extract resources from that plant, and also make a modular plant that allows us to replace part of the plant as new technology and knowledge come in place. So there will be a triple line, a production line, there'll be a research line, and a resource recovery line in that plant. And we've got the whole team in place last month, contractor, architect, and process consortium, which is an international team. It looks very promising. You'll hear more about that. If we take the next one, please, then you'll see Rewater. You'll see Marseillesborg wastewater treatment plant to the left, which is the existing area for the plant, and to the right, your new Rewater resource recovery plant with the yacht club just placed in the middle of that. And that is close to the city and the harbor area, and also within view from the Queen's residence at her summer residence in Aarhus. It's a challenging location, and this plant Rewater will also be covered and put in place, so it will be open for public and also traffic, walking, biking. I think we're inspired by the Chicago lakeside walk when we talk about how the architect had developed that part. Please go to the next one. Energy and CO2 neutrality is possible. I mean, we can do it. We can cover the whole water circle from drinking water to wastewater and stormwater if we want to. And I believe our ambitions are the most important issue here. Climate plays an important role, and it's different all over the world how strong a message that is for driving change right now. But I believe we need to take that seriously also in the future. So please help us with that. And with the last one, you can see, next please, at the bottom, you can see part of that area. That is the resource recovery factories, the chimneys and factories to the left, as the architect imagined the future for Aarhus Rewater. Thank you very much.
Klaus, thank you very much. I'd like to invite our panel to join us. I have a number of different questions, and for the participants, the audience, please enter any questions you think of in the chat window below. We'll stop from time to time and answer those questions. So I'd like to, before formally seeking the opinion and thoughts of our panelists, Klaus, just put this in context. You mentioned, I think we all know there's a lot to learn from Denmark, and how especially this wastewater treatment plant reduces carbon. Lots of lessons that we can apply in Chicago and the Midwest. But I'd like to set the context for some of the differences before we go into what lessons can be learned. Can you talk a little bit about, you mentioned that the wastewater treatment plant at Marseillesborg, there's a fee for pollution and then regulation and innovation. And this is where I'd like to hear from Torvald and Mads, the role of industry in helping guide regulation to meet climate targets. So just first about Denmark's climate goals and what those fees for pollution are, and then how industry can work with the regulators to look towards the future.
These the regulators' drive for change related to climate are linked to our pollution. Our costs are linked directly to pollution, but it's a political set how much we're gonna pay. We pay for nitrogen and phosphorus in our discharge, and so we have an interest in treating our water even better than effluent standards. So we can see the financial benefits. You might say that Aarhus Vand has been turned into a business where we can look at different parameters, but at the same time having the public responsibility. So we cannot run as a business, and we don't work for a profit. We are sort of balancing our economy totally. But it gives incentive for leaders and for individuals to make tomorrow better than yesterday. And I think that's the most important. And there's a lot of details actually of how we are being paid for electricity and how we are gaining benefits also to investing in green production that cannot be maybe directly transferred, but yes.
And then Mads and Torvald, and Nick, I definitely want to hear from you in the U.S. experience, but we'll put a pin in that. But Mads and Torvald, what you see as the experience from Marseillesborg, and what you see as the role of industry in helping shape regulations to meet energy and climate.
If I may start, Mads from Danfoss here, and first of all, thank you for a good presentation, Klaus. I really think, first of all, have we a tradition for a very open talk and work together with the utilities, and I think that is super important in this. And what we see is that, and we see also that in other countries, that sometimes you have a management in a utility which also, without being pushed from anybody else, would try to see how far can you go. And if you then can get support from government, which pick up on that this is in fact possible, and that I think is exactly what have happened in Denmark, and I see it coming up in other countries also, that when government begin to understand that it is in fact possible to make the whole water industry both climate and energy neutral, as Klaus have covered, then at least the Danish government have picked up on it and realized that we have to accept that the water business, for good reasons, are what we call a natural monopolistic market. So that's obvious. That's the way it has to be. There's nothing negative in it. It just means that it is important that the government understand that they are the one to a high degree pushing the industry. And therefore a government who pick up on that there is some guys who have pushed further down the road, as Klaus just have explained, and then pick up on the good ideas. And in fact, I'm encouraging also a lot that the industry, of course, we see as industry now, Klaus have been around the whole globe, but else we see, of course, a lot of what is possible, and putting that together and have a very open dialogue with the utilities and the government is in fact what is pushing this forward. Yeah.
Thank you.
Yeah, I can. In my opinion, it's always it is actually for as I see it. The energy transformation from what I call it old ways to produce energy to the more green way to produce energy started for Denmark already back in 72, where we had the oil crisis. Where we we could not drive a car on Sundays and so on, so we had to find out something, and there we found out how can we produce energy ourselves instead of be depending on outside. So So I think that was where it started. And by that, we also, the Danish governments during the time supported this green transition. And at the same time, also the cost of making pollution started to raise. For example, the cost of disposal of the water quality biosolids has increased, and that's the reason why people make the digesters. And then found out that there is a big energy water quality source in producing biogas from the digesters. So I think that these regulations was the first drivers. But saying that, I think also that the people in Denmark and at the wastewater treatment plants also have acted as what I call it first movers and forward runners of doing this transition. For example, in Mercedes-Benz, I know the guy who has been there for many years. It was really what I call it a strive for him and proudness for him to produce as much energy on this plant as possible, and that drives it also a long way. But today it has turned a little bit about to more about what Claus also talked about, purpose and impact. Today we have limited resources in energy. We cannot. We have to get to reduce our fossil fuel for energy production, and we can do that. And Mercedes-Benz is a good example of those who really want it can drive it very, very long. And that then it become now in Denmark. It's still that they encourage the industry to do it. It's not even a regulation yet, but it comes now to regulations because you can also see it can be done. So those who little dare to do that needs regulation to do it. So I think that is where to stand, and we can see that in United States too. We have been really lucky and grateful for working to people. For example, the plant, as Nick Moninga presented before, and also other plants in United States also have this drive and can see the benefit for doing that. So it's also that Downers Grove plant is now a net energy producing wastewater treatment plant is really the way forward. And we know that this green transition will started in US and will really climb up the next couple decades and so on. I think that was what I want to say.
Well, thank you, Torvald, and that provided an excellent segue to bring Nick into this conversation. So as I mentioned before in the bios, Nick Moninga is recently retired, but was the general manager of the Downers Grove Sanitary District, where they do have combined heat and power and do generate their own energy. So Nick, let's start off fairly broad. I want to get your reactions to, Claus's presentation, what Aarhus is doing, the Marseillesborg wastewater treatment plant, what you see as a manager of a wastewater treatment plant in the Chicagoland region as lessons learned that can the easy lessons to apply in the United States, and then the more difficult ones, and then we can get more specific as we move along.
Sure. Well, I guess to get back to the what you were talking about, on the federal level, the regulatory push. My understanding of the way the regulatory system functions in Denmark is they're significantly more involved in integrating all the different environmental aspects of a wastewater utility. In the U.S., wastewater utilities they're regulated in kind of a bucket system where they're regulated by the water regulators, and they're not regulated by the air regulators at all. And there's very little integration of these different aspects of the wastewater operation in terms of looking at things like basic pollutants that are being discharged into waterways, nutrients, various nutrient loads, and looking at the energy footprint of a wastewater plant. All those things are integrated in the regulatory scheme in Denmark, whereas in the US, they're not. It's you know, there's a very chemical centric view of what you can discharge in your water, and there's very little look from a regulatory standpoint on what's going on with energy or with carbon emissions from wastewater plants. So not really integrated in the US like they are in Denmark from a regulatory standpoint. So I think Denmark has a real leg up in terms of looking at all these various aspects of the operation compared to the US regulatory incentives. Now, that being said, I think operators or local operators in the US are very interested in various aspects of their operation. So on the local level, I think there's a lot of interest in focusing on some of these things. There still is a significant pressure in the US on the bottom line. I think there's always pressure to keep your rates low for your customers. And that's something that any elected or appointed board is going to be very excited about. So there's always motivation to keep the cost under control. And not only that, but the environmental aspects of doing things like reducing energy or producing energy using renewable resources at a wastewater facility also it's kind of part of the triple bottom line that you get by doing that type of a project, where you have this environmental benefit in addition to an economic benefit, and probably one of the more important things in my experience that people don't often think about was the social aspect of it. The community, customers in the community are very interested in the fact that your wastewater utility in your town is actually producing energy. It makes you feel a lot better about flushing that toilet every day. And it helps different various aspects of the community. I mean, it makes, commercial or industries in town get to brag about that because they're participating in that. People, want to live in a community that has that aspect to it. So the realtors can use that as like a selling point when they're selling property. I mean, so it's a triple bottom line kind of thing for local operators. You get social, economic, and environmental benefit from doing this type of project. So
well, that last point, that's a really interesting, and I'm interested to hear, Klaus, your experience with, what is the public's experience with the current Marseillesborg wastewater treatment plant, and what is the public's experience or participation in the design for the rewater plant? And then as a technical question, will the rewater plant discharge water into the bay, or is the idea that the water will be purified and released into the clean water drinking supply system? So maybe reverse those and answer the technical question first.
Yeah, I'll answer the last one first of all. We have plenty of groundwater in Denmark, and that means we take clean groundwater up and pump it to our customer. But the focus is actually reuse of some of the water from rewater. And that is because we have so much water, and we think in principle it's wrong just to discharge it in the bay with clean water. So we want to find alternative use. Today it's been, we have some wastewater being used in a power plant for cooling system, and we want to find industrial use for the water also. But I don't think we can do it for all the water, but maybe for some of it. So that is a development we try to learn from the US. That's about reuse of water, and especially in new development areas where we take rainwater and bring it in for toilet flushing and washing clothes. You may be reducing then the use of water by 30% or so. And that is something we learned a lot from California, especially. So that has been brought in. If we take the public interest in the rewater plant, because we're doing environmental impact assessment right now, and that is actually to prepare the discussion of how that plant should interact with the not only the environment but also people. And I would say we are what we're doing at that plant meet people's expectation. And I think that is because that the people in Denmark expect us to behave the way we do. We are not setting higher standards than people really expect. And they are willing to pay also for the water and the services that are included into building a plant like this. And that is somehow a surprise and maybe different from many other cities or areas. And we benefit from that. They are more concerned of putting a new plant just in the bay and next to the yacht club and what will happen. But you see, the old plant is there and it's really not causing any trouble odor-wise or so. So that'll probably work out very well. And we want to have people around the Wastewater more engaged in this plant, either university researchers, schools, which we have today visiting us already, but also people who are taking a stroll in the city, being able to see what a wastewater treatment is like, and especially when it comes to resource recovery, recovering phosphorus and other stuff. I mean, being an education site or could be useful too. So there are many aspects also. And the last part is to make bankable products, so to speak, to make sure that new product can be tested and also measured, so to speak, to see how useful are they in a certain plant. But we are not as involving in many as you are in many places in the US, where the community is so much more involved sometimes in your project and participation.
For better or worse.
I'd like to add a little story to Klaus's discussion. I visited Aarhus Van, I don't know, maybe 10 years ago now, on a trip just to visit some of the plants and see some of the technology. And the cab ride from the airport to the hotel, I told the cab, he said, why are you in town? I said, I'm here to visit Aarhus Van. And he bragged about how they were really good at resource recovery and energy recovery. The cab driver knew about the water utility and he was bragging about it. So from a social perspective, people in Aarhus, they appreciate what they've got and they know it. So your PR must be really good.
Thank you. Yeah.
If I may,
please.
I may comment on it. I think also that what started partly in Aarhus, you can also see other utilities in Denmark are trying to catch up. So it also have that consequence. So one thing is what the people think in Aarhus City as such, but Odense can more or less do the same, and Copenhagen can do the same now. So it of course is spreading among the different utilities that this is possible, and therefore the people in Copenhagen is looking for the same thing. I think that is the important point. And now where I'm talking, I think there's also, which Klaus didn't cover really, about the facility, that sometimes I get questions, how much water or carbon are you then getting in from other places? How much wind energy do you have, or how much do you have, or what do I know? What I think is important here, because that's why it can be copied. That is that what Klaus have on the Marseillesport facility is very traditional activated stock treatment plants and household wastewater. There's no tricks, there's nothing of external things coming in. There's no windmills, there's no heat pumps, there's nothing. And that's what I think is really making it interesting, because then you can copy it to other places. And I think also digitalization as a real-time measurement, that is a key. Klaus mentioned that maybe 70% of the improvement is coming from that. There's a lot of sensors in real time, computer control, and a lot of wireless speed drive, which is the precondition for operating the facility so efficiently. Yeah. Yep.
I would like to comment a little bit also on this, because the efficiency of Mercedesborg plant and also other Danish wastewater treatment plants, also the ones we have turned to net energy producers in Chicago, is the integration. Integration is so important because it's every plant is different. So it is also to look into the plan and see what is possible in different areas. So therefore, integration, thinking of the integration, and also what Nick Moninga talked about, that we are looking in a holistic way. We have to take it to the next step. I think we need in Denmark to be even more integrated and make more coupling of different sectors: energy sector, environmental sector, water sector, and what I call it resource sector, and more in circular economy. That is a way to bring it even more further. So, for example, in Chicago, we also discovered that we was not allowed to export the electricity when we started over there, because you know that it was only the plant's own electricity. But today, the electricity companies is a little bit more interested in having this, because the energy grows, the energy consumption grow, and they sometimes in the areas need and can see benefit of this local production of energy to stabilize the grid. So this coupling of sectors and integration, I think that is really important in having the efficient energy wastewater treatment plant.
Excellent. And that leads to a question that I got on my phone, and we have some questions in the chat before we end, is your experience, Klaus, with your electric utility? Because as Torvald mentioned, it is difficult to export electricity to the utility. The Downers Grove plant, to my knowledge, and correct me if I'm wrong, they don't export electricity. It can be done, but
no, it's Downers Grove now has a two-way meter, so they're actually putting electricity into the grid with ComEd, and it varies from electric utility to electric utility. So, like in Wisconsin, I think you basically have two wires, one in, one out of a plant. So you're selling whatever you produce into the grid, and then you're buying what you need through a separate wire. But in Illinois, you know, the rules did change. I think it was primarily the solar and wind industries that got the rules changed on how electricity is regulated in Illinois. See, they just basically forced the utilities to accept two-way meters for any application, so anybody can produce electricity and put it back in the grid. And you know, the electric company has to figure out how to you know, manage their system so that works, and they're able to do it. So that's yeah. It varies from, you know, utility. Even in Illinois, we're in two different power grids, PJM, and then the one in Southern Illinois. It slips my mind what it's called. MISO, I guess it is. Yeah. So and yeah, MISO and PJM have different sets of rules for how you get the electricity back into the grid, but you know, but it's so there's some variability of how electricity works. And I did notice there was a question about other things besides electricity, and vehicle fuel for biogas, converting it into vehicle fuel is certainly a viable thing to do in the U.S. and you know, around the world. So that is another thing that should be considered by anybody who's looking at energy recovery with looking at anaerobic digestion of biogas. The subsidies right now for renewable vehicle fuel are really good. So if you can get a project done fairly quickly, you can get a pretty quick turnaround with the current environment for renewable fuel subsidies. So that certainly is a viable thing to do. The hard part is just finding the vehicles to uptake the gas. I mean, you have to have some CNG fleet somewhere that's willing to use the stuff. So So that's kind of the challenge with that. But the technology certainly is available to make vehicle fuel out of biogas. It's not a difficult engineering feat at all. It's a simple thing to do. So.
Well, I wonder,
Mads,
you had
I
to...
maybe could comment a little bit on that, because the reason why we can sell the electricity into the grid in Denmark was that during the transition there, the government decided to make a law that the electricity company has to accept renewable electricity or produced electricity into the grid. So the connection issue was not that a big issue after this law was, but so therefore it was easy to connect. And to comment on your, I think that's also the future, to make the gas into vehicle fuel and so on. But in my opinion is that the wastewater treatment plants should at least cover their own electricity, because they can do, and they need heat and electricity at the same time. And that is the most high efficient you can use the gas, because putting the gas on a vehicle, you get 30% out of it instead of 85% when you use it in a CHP.
Mads, I noticed you had your hand up. Did you want?
Yeah, it was just a short comment on that. That I agree basically with what Torvald is saying, but just to reflect on it also, if you go to Copenhagen, where they have done close to whatever Claus have done, they are producing electricity, but they're also producing gas for the natural gas network. So that of course is another possibility. So we see different solutions around how the gas is used. And just on that note, I know it probably cannot be used a lot in US, but I think it's worthwhile that one of the trends going on also here in the northern part of Europe is to take the heat out, or that the wastewater have a higher temperature and use heat pumps on the outlet from the wastewater facility. Have in fact been calculated that we CO2 neutral can heat 20% of all houses in Denmark. And that means, in fact, that some of the people looking at sustainable cities, as a way, if you can imagine a city being completely CO2 neutral one day in 5 or 10 years' time, then the water utilities is expected to be a part of the energy network, and an important part, for the simple reason that you can produce a lot more energy than what we are talking about right now, if else you have a district heating system. What we see in France, we see other places where they don't have district heating, is that they are heating the local swimming pool or whatever they are doing. So we probably will see creative solutions, but it is in fact very attractive to install heat pumps on the outlet from wastewater facilities. So if we meet in 5 years' time, I think we'll see the water business have moved even further on that agenda. Yeah.
Yeah, that's really cool technology, and just another a way to squeeze as much energy efficiency out of the process. Well, with that, there's one question in the chat, and let me see if I can phrase this, and then we're going to have to end this. But is there, and I think this is to Claus and Nick, but everybody pan in, is there a counterbalance to the energy savings? Is there any difference in the water quality or equipment needed to get these energy savings? So what is the, is it just cost? Is it just expertise? I think that's where the question's coming from.
Yeah, I saw that question. That's an interesting question. Really, when you look at energy recovery in the footprint of a wastewater plant, it's kind of separate off on the side from the water treatment. So it really tends to not have an impact on the quality of the water that's discharged at the back end of the plant if you're doing energy recovery. Now, if you're trying to make your process more efficient, you can actually get both benefits. So if you introduce like denitrification in a wastewater plant, you can reduce the amount of nitrogen in the discharge, and you can reduce the energy use at the plant. So you can make yourself more efficient and produce better water. So it's actually, you get multiple benefits sometimes from some of these activities. But the real obstacle is there's a capital cost associated with putting these facilities. So you have to come up with some capital money. You have to come up with some cash in order to pay for the facilities that you install. And then it makes your operation more complicated. So you have to have people who are able to maintain this new types of equipment. And you have to have operators who understand how to operate them and things like that. Now that's with energy recovery equipment. However, if you're doing things like making your plant more efficient, a lot of that comes down to automating the facility, which actually makes it easier to operate. So but with automation, you can reduce the number of people that you need, and it kind of changes the expertise involved in operating a facility. So by making it more efficient, you can actually make it a better place to work and a easier place to operate. So that you get double benefits. So with a lot of these things, you actually get multiple benefits rather than having to weigh, am I making worse water when I do this? You're not going to make worse water doing this, but sometimes it can be difficult to come up with the capital that you need in order to install the facilities. So that's kind of what you're weighing, what you're trying to offset.
Absolutely. And Klaus, I'll leave it with you for last thoughts on that question or
Nick,
any others.
Nick, I will appreciate your answer. I believe that's true, and I think some of the risks are more that people could have a feeling of lacking control of what's going on if they do something different at the plant, and that is where you actually need a good friend somewhere to help you, or to make sure that you don't hang if you fail. But you don't have to fail. I mean, it's not necessarily a difficult way as such. Take it step by step, integrate, feel comfortable about the next level, you take it, and then walk the line. That's probably the best learning that, and also the way we have done. To do this in a week or 2 or 3 months, I believe it's impossible. But to take a good step, and Nick, like you have done in your previous plant, is a very good development. And as you can see from our curve, we talk about 10, 15 years back to do this development. And better start today than tomorrow. I mean, because this is not going to go away. This is going to happen. And you're benefiting not only to the water quality, but also to the climate emission. So I think that will be something that you might consider in the future that are more important than it is today, that you can take into consideration walking down that path. And then another perspective is also that you get different qualification. People with automation, IT skills, sensor skills, and so on, that's the people of tomorrow who is going to work at the plant. So to transfer new knowledge and technology into the plant now also make sure that you can attract the future's workforce. And that is important.
Well, thank you very much. I think this was a fantastic session. I think we could keep going for at least another hour, but sadly we have to wrap up. So I'd like to thank all of our panelists, Klaus, Mads, Torvald, Nick. Thank you so much. And for all the participants who've stayed with us this hour. Thank you so much.